Hello everybody. Today's lecture we are going to learn about a very important topic. Geotechnical engineers called origin of soil and grain size. Our topic is firstly rock cycle and the origin of soil. First, you need to know about the three different types of rocks. First one, igneous, sedimentary rock, and the metamorphic rock. Each of these rocks has a unique way of forming and can even transform into one to another. Let's start by explaining how igneous rocks form. This volcano looks like it's about to erupt. Beneath Earth's crust is liquid magma. Liquid hot magma makes its way above ground. It cools and hardens over time into new rocks that form are that we know as igneous rock. That rocks it formed on the ground surface. It's mean extrusive. If that formed below the ground surface like that means intrusive. Now let's talk about sedimentary rock. First of all, sedimentary and the metamorphic rocks can become igneous rock by melting and hardening. This is our coastline and this is our ocean, sea or lake, and we have igneous rock and transportation of weathering due to ice, water, wind or gravity. And the sedimentary rocks are composed of loose sedimentary and now compaction and sedimentation bind these sediments together with pressure and other earth elements, specifically water. And after this process, we called form that is sedimentary rock. Let's talk about our last types of rock, that is metamorphic. Here is my earth surface, and this below the surface there is an liquid hot magma, maybe it's changed to igneous rock, and now transportation of sedimentary or igneous rock to metamorphic rock due to heat and pressure. This form called as a metamorphic rock. Now rocks have been forming and transforming for millions of years. The earth is made of rock, and now we know how they form. Let's continue. Now our topic is weathering. That is process of breaking down rocks by mechanical and the chemical process into the smaller pieces. Mechanical weathering may be caused by the expansion and concentration of rock from the continuous gain and loss of heat. which result in ultimate disintegration. This mechanic weathering by water, glacier, wind, thermal expansion, freeze, or gravity. This mechanical weathering related with the gravels and the sand cores. Or other weathering processes, chemical weathering. Acids and salts react with minerals to form smaller particles and clay minerals. Products of weathering sediments as a new minerals related with the fine grain. Let's talk about the transportation of weathering products. The soil formed by the weathered products at their place of origin are called residual soil. An important characteristic of residual soil is the gradation of particle size. Fine-grained soil is found at the surface and the grain size increases with depth. At greater depths, angular rock fragments may also be found. The transported soils may be classified into several groups, depending on their mode of transportation and the deposition. First group is glacial soil, formed by deposition in quiet lakes. Most famous example is glaciers. And other groups, alluvial soil, transported by running water and deposited. Two examples are streams and the running waters. And the third group is related with the formed by deposition in quiet lakes. And the other group formed by deposition in the seas. And the next group is related with the wind deposition, transported and deposited by wind. And our last group is related with the formed by movement of soil from its original place by gravity, such as during landslides. As we see that this transportation by ice, water, wind, and gravity. Now we talk about soil particle size. This subtitle is very important for us. As discussed in the preceding section, the size of particles that make up soil vary over with range. Soils are generally called clay, silt, sand, and gravel, and depending on the predominant size of particles within the soil, they describe soils by their particle size. Several organizations have developed particle size classification. This is our main classification. Silt and clay part of fine grained, and the others soils in part of coarse grained. And silt and clay have specifically properties that is cohesive. These properties related with their shapes, flaky particles, due to surface forces, and the others cohesiveness properties, and because of that they have bulky particle shapes, and the effective forces is gravity. Clay minerals. There are several clay minerals. The two basic building blocks for clay minerals are silica tetrahedra and alumina tetrahedra. These are molecular form, and when integrate each other, and those are their sheet form. There are several clay minerals, but three that are must come: kaolinite, illite, and montmorillonite. This sheet includes these blocks. Specific gravity is our other important subtopic. Definition ratio of unit weight a given material to the unit weight of water. Recurrent value for soil mechanic calculation parts. For pure minerals, it can be used for identifications. Soil are mixture of minerals, hence we determined specific gravity for soils in the laboratory. And for sand, our specific gravity is 2.65, and clay and silty soils equal to generally between 2.6 to 2.9. Mechanical analysis of soil. Why in the particle size distribution analysis important? Because of the predict of soil behavior, soil classification, and predict how the engineers the soil. There are two types tests that are performed to mechanical analysis and hydrometer analysis. Mechanical analysis for gravel, sand, and fines. Hydrometer analysis just for fines, silt, and clay. Mechanical analysis wash or meshly shake the soil through a series of sieves with various size of mesh. Cannot mesh to separate soils smaller than 0.0075 mm. These are usually considered fines. We have a formula, and in the measuring part, determine the mass of soil retaining each side, and determine the total mass of soil, and determine the cumulative mass of soil, and we can find the percent of soil passing. Another test is hydrometer analysis. Fine-grained soil mixes the water and grain size distribution is correlation with the rate of sedimentation. We will use Stokes' law. We have a very important equations and in formula represent them and other equations. In my next video will include this formulation part, and I will solve a question related with these equations. Because of that, I am jumping them. Particle size distribution curve also are another important subtopic. Distribution curves are used to plot percent finer versus particle diameter. And a coarse-grained soil, as in gravels and sands, are either poorly graded, gap graded, and well graded. If most soil grains are the same size, it's represent poorly graded or well sorted. If most only soil grains are distributed over a large range, it represents well graded or poorly sorted. Those are only coarse-grained soil. We are continuing particle size distribution curve. A particle size distribution curve can be used to determine the following 4 parameters for a given soil. This parameter is effective size. This parameter is the diameter in the particle size distribution curve corresponding 10% finer. The effective size of granular soil is good measure to estimate hydraulic conductivity and the drainage through soil. Other parameters is uniformity coefficient. Is defined as like that, where diameter corresponding to 60% finer. And the other parameter is defined as coefficients of gradation and represent this equation. And our last parameter is another measure of uniformity and is generally encouraged to geological works and expressed as this formula. The shorting coefficient is not frequently used as a parameter by geotechnical engineers. To sum up, in this chapter, we discussed the rock cycle, the origin of soil by weathering, the particle size distribution in a soil mass, the shape of particles and clay minerals, and some important points include the following. Rocks can be classified into 3 basic categories: igneous, sedimentary, and metamorphic. Soil is formed by chemical and mechanical weathering of rock, and based on the size of the particle size, soil can be classified as gravel, sand, silt, or clay. And clays are most of flake-shaped, microscopic, and submicroscopic particles of mica, clay minerals, or other minerals. Clay minerals are complex aluminum silicates that develop plasticity when mixed with a limited amount of water. Mechanical analysis is a process for determining the size range of particles present in a soil mass. Sieve analysis and hydrometer analysis are two tests using the mechanical analysis of soil. That's end of the presentation, and feel free to send me email and add me to your professional network. So thank you for your time, and have a wonderful week.